Hi, welcome to another episode of Science Made Simple. I'm Mr. Ryan and I'm a secondary science specialist here at the Pique Lab. In this video, I'll be analysing a past year exam question. I've also prepared this question for you to download for free by clicking a link in the description box below. So, let's get started. Let's take a look at this question. It says, which of the following salts can be prepared by the methods indicated? This question is talking about salt preparation. To prepare salts, there are three main methods: precipitation, adding an excess, as well as titration. Which method should I choose? And how do I select the method? To select the method, you need to work backwards based on the salt that you are preparing. So let us classify our salts first. In our salts, we have two main kinds that you should learn from your solubility table. The first kind is your insoluble salts, and your second kind is the soluble salts. Now, insoluble salts, are they going to be solid or are they going to be aqueous? Since they are insoluble, they will form solids. And what about soluble salts? Since soluble salts means they can dissolve in water, it means that we will form an aqueous solution. Next, what method should I choose to prepare these kinds of salts? For insoluble salts, we will use only one method, which is precipitation. Why? Because precipitation means to form a precipitate, which you should know is a solid. And what do we use in a precipitation reaction? In a precipitation reaction, we are using aqueous plus aqueous. Next, we have soluble salts. How do we prepare them? We will use two main methods. The two main methods are addition in excess, and the other method is titration. The question is, how do we select between addition in excess and titration? The way that you can remember that is that for addition in excess, we will use non-spar salts, and for titration, we will use spar salts. Spar stands for sodium, potassium, as well as ammonium. So the moment you see sodium, potassium, ammonium, you know that that salt is going to be soluble in water. Now, for addition and excess, what are we adding in excess? We are adding a solid in excess, and we are adding it to an aqueous salt. For titration, we are going to add two aqueous salts together to form an aqueous salt. Before we dive into the table, please take some time to write down the state symbols of each of the salts that are being written here. You can use your solubility table, or you can take this chance to see whether you remember the solubility table. Pause the video here, and I'll review the answers to you after the pause. Did you get these answers right? If you didn't, please go and look at your solubility table again and see whether you have used it correctly. Now that we have the state symbols of all of these, let's take a look at the column header and see what method they are suggesting. On the left-hand column, it says that they are using an acid as well as an insoluble carbonate. An acid, is it going to be solid or aqueous? An acid can only act as an acid when it dissolves in water to release H+ ions, which tells me that this acid must be aqueous. What about the carbonate? It says insoluble over here, which tells me that this must be a solid. This method here is therefore aqueous plus solid, and which method does this correspond to in the flowchart below? This would correspond to the addition in excess method. Now, addition in excess, what kind of salts are we preparing? We are preparing soluble salts, which means we are only looking at the aqueous options. Immediately from this, we can cross out option number 1 because option number 1 wants to prepare a solid. Next, we notice that for addition in excess, we are trying to prepare non-spar salts, which means the salt should not contain sodium, potassium, or ammonium. Look at the options 2, 3, and 4 and see whether there are any that correspond to this. So for this, you realize that option 3 has the word sodium in it, and therefore we can cross out option 3 already. Now to look at option 2 and 4, how do we select between these two? Let's take a look at the right-hand side and see whether we can eliminate any other option. Here it says that it is being prepared by the use of two aqueous salts, which means that we are trying to do aqueous plus aqueous. Which method does this correspond to? Notice that this actually corresponds to two methods, right? Precipitation and titration. Now, ask yourself first, for precipitation, is there any solid that is left in 2 and 4? Yes, there's option number 2. And do we know whether option 4 is going to be correct? No, because we have not checked out titration. Let's take a look at titration then. Titration is trying to prepare aqueous salts, and specifically what kind? They are trying to prepare the sparse salts. Are there any sparse salts in option number 2 and option number 4? No, there are no sparse salts here, which means that we can immediately eliminate out the option of titration. Therefore, since the only solid left there to be prepared by precipitation is calcium sulfate, it tells me that the answer is immediately option number 2. Now, to confirm why option 2 is the correct answer, let's take a look at the salt that is being prepared and ask ourselves what it can be prepared by. So, iron 2 sulfate, iron 2 Fe2+, and sulfate SO4 2-. Iron 2. Will iron 2 come from the acid or the carbonate? Iron 2 will come from the carbonate, which means that it must be prepared using iron 2 carbonate. Is iron 2 carbonate soluble or insoluble? Iron 2 carbonate is an insoluble salt. Therefore, this makes sense. Now, sulfate. What kind of acids will produce sulfate salts? The acid that will produce sulfate salts is H2SO4. And therefore, iron 2 sulfate being prepared by the use of an acid and an insoluble carbonate makes sense. Let's take a look at the right-hand side for calcium sulfate. It says that they want to use 2 aqueous salts. So let's write down the 2 ions first. Calcium is Ca2+ and sulfate is SO4 2-. In general, if we want 2 aqueous salts, the easiest option to choose is for calcium. I will always select the nitrate salt because nitrate salts are always soluble, which means I can use calcium nitrate. And for the anion, what will I use? Think about what salts are always soluble. We have written them down over here, which means that you can use sodium sulfate, potassium sulfate, or ammonium sulfate, and you will definitely always get an aqueous salt. So we'll write down here, you can use a sparse sulfate. And therefore, you can prepare calcium sulfate by the addition of 2 aqueous salts. This confirms that the answer is option number 2. Thank you for watching, and I hope you have enjoyed this video. Found this video useful? Give us a thumbs up and check out more by clicking the links over here. You can also subscribe to our channel for more interesting videos. Until next time, stay curious inside and limitless outside. Bye!